So, hi guys, welcome to my YouTube channel Code for Fun. So, today I'm going to discuss two lead code problems. So, first is the problem number 2419, longest subarray with maximum bitwise sum. In this, they have asked to find the length of the longest subarray with maximum bitwise sum. So, let's see what they are given. Let k be the maximum value of the bitwise sum of any subarray of nums. Only subarray with bitwise sum equal to k should be considered. Return the length of the longest subarray of n. So first let me explain the problem. So if there is a array of 1, 2, 3, 3, 3. So in this the maximum bit and possible is, so you write the each number as bits. So it will be like 0, 0, 0, 1 for 1, and for 2 it will be 0, 0, 1, 0. So starting it all will be 0 for both the numbers. So for 3, it will be 0, 0, 1, 0, 0, 1, 1, and so on. Starting also will be 0. So the maximum bitten means uh, which is the maximum bitten of the subarray possible. So in this, the maximum bitten possible is 3. How can we say this? Like, so this, if we write it as bits, it will be like this 3. So we should consider 3 and 3 and 3. 3 and 3 and 3. So when you write that, it will be like 0, 0, 0, 0, 1, 1. And of this, all digits will be 1 and 1, 1. So all will equal to simultaneously equal to this 1, 1. So basically, the problem states that to find the length of the longest subarray with the maximum possible bitwise end. As I told, bitwise end is end of each number. And of all the numbers or and of what numbers in the subarray. So when you consider a number, the maximum bitwise possible for an array will be the largest element of the array. So how I say is like, so let's consider 1, 2, 3, 4. So if you write this as a bit, what will you write? So consider this as a subarray, this as a subarray, this as a subarray, this as a subarray. You consider anything as subarray, and whole subarray and should be equal to the largest. So one can be written as I already told 0, 0, 1. 2 can be written as 0, 0, 1, 0. 3 can be written as 0, 0, 1, 1. And 4 can be written as 0, 1, 0, 0. So when you do the maximum possible and for this array, it will be always 4 only. 3 is also possible, but as they asked maximum possible and it will be 4. How I say is like when the largest element, when we do a and with the largest element, all the elements which get multiplied, like which gets and with the largest element will always equal to the largest element. So, for example, when we do 1 and 2 and the maximum possible and is 0 here. 1 and 2 is 0. So when you see 1 and 3, 2 and 3, here the maximum possible and is 2. So the maximum possible bitwise and of an array will be the largest element ever. So it should be alone. That is, the subarray should contain only the largest element, or the subarray should contain the continuous elements of these large elements. That subarray only will have the largest bitwise and. As we already saw, the maximum possible and for an array of or of two elements will be always equal to the largest element. So when we take equal elements and, you'll get the same element. But when we take a smaller element and larger element and, it will be, when we take a smaller and larger element and, it will be always, let's get this as an x. So x will be always less than or equal to 3. Mostly it is less than 3. It will be always less than 3. So to get the maximum possible and, it should always be the largest element of the array. And as they already asked the length of the maximum possible bitwise and of an subarray. So the subarray should contain only the largest element, that is 4 comma 4 comma 4, if this array contains like this. So your maximum possible length is 3 4 4 4. So yeah, that's the main concept. So the main concept, as I already told, the maximum possible and for two element will be always less than the larger element. So when you go on up to two or more than two element also, it will be always less than the larger element. If elements are equal, then the largest possible and will be the same number. As one and one of the each bit of the numbers will be one, and zero and one will be zero, so on. So yeah. So what I have done is at starting, uh, I found the maximum possible element of the array. So this is a STL present in C++. You can use a for loop and find the maximum possible element. Then I have taken variable known as curlen and answer. So for each element in the array, I am finding first if the num is equal to the maximum possible element, current length will increase by 1. If the num is not equal to maximum element, then current length will be obviously 0. When there are continuous number of maximum elements, then this current length will so on, keep on get increasing. So, and I'm storing when that comes to an end. So when there are continuous possible larger elements, let's say uh, when there is 1, 2, 3, 3, 3. So first my curl length will be 0 here as it is not equal to maxi. Maxi is the maximum possible one. Here also curl length will be 0. Then when I go here, the curl length will get increased. So curl length will become 1. So keep it as 2. So here curl length will become 2. Here curl length will become 3. So when we take a smaller element than that, or the element which is not equal to the maximum element, it will go to the else statement. As you can see, else statement contains maximum answer equal to maximum of answer comma current. So maximum possible current length possible. So first I'm taking it. After that, making the current length as 0 as the subarray got completed. So at last, I'm not returning answer. I'm returning maximum of answer comma current length because this answer max contains only the largest. This answer is being considered only when the element is not equal to the maximum element. So we can also keep this answer as outside the for loop. It doesn't matter at all. And here you can return answer. Otherwise, what if the array gets completed with the maximum element? So in this case, if this 2 is not there, then the current length will be 3, but the else condition won't work. So at last, current length will be 3, but answer will be 0. So you should not return it. That's why I had a maximum of answer comma current length. We can also have it here. And let me run and check. Uh, as you can see, problem runs and the code works. So the main core concept is maximum possible bitwise and of any array will be always less than or equal to the uh, maximum element of the array. This is the core concept. As I already mentioned, it completely relates with the bits of a number. So we no need to do any bit manipulation or bit operation in this case, and the code works. So yeah, this is the first question. Here guys, next is the maximum product of world lengths. Problem number 318 in Leetcode. So you are given a vector of strings, vector of string or list of string. You should you should get the maximum value of length of word I into word j where two words do not share any common letters. If no such two words exist, return 0. So in this case, if you check A, B, C, W and X, T, F, N doesn't contain any character in common. So the length of A, B, C, W is 4 and X, T, F, N is 4. So when you multiply that, you'll get 16. So yeah, that is the case here. Here A, B and C, D doesn't contain any character in common. So it is 2 cross 2, that is 4. Here every string contains A. So obviously the length will be 0 as any two strings. Like if you consider always there should exist some two strings which should have all characters different. So let me start explaining the problem in this case. So if you see this problem also, I can do in two ways. First is I can take a vector of length 26, and for each character I can store the vector of the count, or like bool of vector, that is list of vector. So I can take a vector or list of length 26, and for each character, if the character is present, I'll mark that vector as 1, and if the character is not present, I'll mark it as 0. And then for each string from I equal to 0 to n, and for j equal to 0 to I, I will check whether both the I and j doesn't contain any position as 1 in common. So that's what I will check. So this is bit of a lengthier method. So we can, as we know, the smaller alphabetical characters are only 26. So I can use a int to store it. So usually integer contain 32 bits, as we all know. So it will be always like 0. The 0 will contain like 32 zeros. So for each character in the alphabet, like smaller character, I will consider the bit as the character. So when A is there, I will mark the bit as 1. When B is there, I will mark the second bit from last as 1. When Z is there, I will mark the 26 bits from the last as 1. So this is the main core concept. Taking an integer and storing whether if the character, smaller character is possible or not, is present or not. So this is the main core idea of the problem. And as we all know, the bitwise operations usually cost very less, like constant of time. So that's why we recommend this rather than 26 into 26. Yeah, let me go with the code and try to explain. So first I'm taking a vector of long of map known as MPP. This is a like list of integers. I used long here, you can also use integers. So for every word in the words vector, for each word, I'm going through all the character in the word. So here int x equal to word of I minus a means I will like A's ASCII value will be subtracted from the character's ASCII value. So for A, if the ASCII values, so for each character, so if the character is A and I do a subtraction of A, you will get a 0. And if it is B minus A, I will get a 1. So ASCII character of smaller b will have 1 more than the ASCII character or ASCII value of A. So that's what I am doing here. So next, so I have did an OR operation here. So generally, normally I consider a int of variable known as bitset, and I have did an OR operation with a left shift operator. So your left shift operator is I'm 1 LL, you don't consider that LL and all, it's just a 1. So I'm pushing the L with like X position. I'm pushing, if one left shift operator of X means, so one left shift operator of X means I'm pushing 1 to the ith index, the ith bit of the number. So it is like if I have 0, 0, 0, 0, and so on. If I do one left shift by 2 means I'll push that by 2 indexes. So 1, if this is 1, so I'm pushing it by 2. So it will go to the second bit from the 1 from the 0th position. So it will be like 0, 1, 0, 0. Yeah, so I'm basically getting the ith bit of each character, and I'm doing an OR operation in order to store all the possible character in the word all the possible character in the word, and I'm just marking it as present or absent. Then I'm pushing the bit set inside the MPP, that is vector of int. So yeah, if A is present, the zeroth bit will have 1, and as I'm doing OR, the 1 doesn't matter at all. If there is an if there is an A and B present, so first I will do an left shift of 0. So A will 1 will be here. This is the bit set currently. Then I'm having a B. So for B, this X will become 1. Next I will do a 1 left shift 1. So if I do an OR operation with this, that is 0, 0, 1, 0, as you can see, the answer will come as 0, 0, 1, 1. So in total, I have got like A is present and B is present. I have got both A is present and B is present in the single integer. So that's why bit is very useful here. Next, we already know like both the I'm looping over the all the words in the all the word in the words vector, and then again I'm coming from 0th index to the ith index and checking for each index is there any possible some other index, as both the words should contain completely dissimilar characters. So I'm doing an AND operation. So what happens when you do AND operation is so what happens when you do AND operation is 1 minute. So consider there is A, B, C, D. So for this, the bit set will be like this, and for this bit set is 0, 0. So when I do AND operation over here, 0 multiplied by 1, 0 multiplied by this 1 multiplied by this 0, and 1 multiplied by this 0, we will completely get 0. So for when both the words contain, both the string contain completely dissimilar atom, always the bit set will contain 0 in one string or some other string. So that's what we want. So if it is always equal to 0, then we can surely say both contain completely dissimilar characters. But there are also some other cases where it is common. So I will say like AB and AC. Here the bit set will be 1, 1, and here 0, 1, 0, 1. So when I do an AND, this last 1 and 1 will always be an 1. This will become 0. First bit from the last and second bit from the last will always become 0. So I'll get some 0, 0, 1 or something. So this is not equal to 0. So by this we can clearly see if there is a common character in both the strings, there will always be a bit which is equal to 1. As AND of both the bit will always be 1. 1 and 1 is 1. So that's what we got. So I'm checking for it that MPP of I means the bit set of the ith word and bit set of the jth word. If both are equal to 0, then I'm just multiplying the length of both the words and storing it in the answer. And at last, I'm returning the answer. So this almost runs with the time complexity of O of n square into, it's almost runs with the complexity of O of n square, as this is doing in a constant time. If you use vector of vector, then it will contain, it will take almost 26 into 26 again. So yeah, this for the second question.